Hello, welcome to the session. This is Suresh, Faculty of Chemistry from Infinity Lane. How are you? Good afternoon, my dear children. Shohani Tiwari, good afternoon. How are you? Anamani is there online. Welcome to the session. Today we are going to discuss the most amazing topic, the arenes from the Organic Chemistry grade 11. So, what is arene? Before going for this arene aromaticity and preparation properties of the benzene ring and its reactions, I just want to take care of certain things from the Infinity Lane, what Infinity Lane is doing for the student community preparing for NEET examination. Here is an example of 4 students here, Ashrita and Himadyuti, Akhil Verma and Satyanarayan. They secured almost a double score as compared to 2023 and 2024 तक. अरे 2023 में they got just 310 marks, and after enrolling a few courses from the Infinity Lane, they got 661. You can check this 350 marks in लोगों को बढ़ गया. And also you can see Akhil Verma 313 marks in 2023 NEET examination, they got 658 marks. There is a 345 marks increment in 2024. How? Good afternoon. Right. So, how this is possible? NEET 2023 versus NEET 2024, there is almost the score is doubled. Yes, this is possible only by Infinity Lane academic programs. So, you just click this description box that is given, and you can check the courses that are available, and you can enroll in any one of the course, so that you will be the next student to displayed here on the slide. Ready for that? And also you can see crack NEET. Just simply you can attend these YouTube sessions day by day, every day, and recording sessions also, and please like and share and subscribe this, and you can see this, you can download Infinity Lane NEET test prep meta app, and you can just go through the all live classes, mock test, create your own test, and 24/7 doubt removal systems. And also Infinity Lane is there on the social media like YouTube and Instagram and Facebook and Telegram, and you're not many things, so you can get it here. I just want to say, join in your Telegram channel, so that you will be having a daily quiz in this Telegram, and session schedule. Every session has its own notes, so the session notes and session assignments and many more, you just, link is given in this description box, you can join there. And also you can say pathway to academic success, learns journey with Infinity Learn. This is AI driven program. You will be having doubt resolutions for 24/7, and also you will be having a goal settings and self study and many more test and preparation analysis, artificial intelligence driven program, that is AI guided academic programs. So, everybody, you please mention one more important thing, and last but not least, that is about the score. What is score? This is your score examination. It is the India's largest scholarship exam for grade 3 to grade 12, and it is a score examination is completely online. Sri Chaitanya talent test. We can say, let's make success is possible. This score test, and you will be having a scholarship worth 1 crore. Can you imagine? Can you imagine? And it is a 100% scholarship test. So, and study setup and laptop, study table, everything आपको मिलेगा. And also educational allowances भी है, and also 100% स्कॉलरशिप टेस्ट भी है आपका स्कोर का हिसाब से, है ना. कल्पेंद्र, हाउ आर यू बेटा? And also you have a registration form, and it is a pinned messages, it is available there. You can click it down and you enroll on the score examination. Yes, that's very good. How are you, Kapilendra? Not seen the previous class. Array, you're coming and just kept in the quiet. And what late we are going to start arenes. Chalte? So this particular chapter arenes, what you learn, we are going to learn aromaticity, introduction to the structure of benzene and the preparation of benzene, and electrophilic aromatic substitution reactions of benzene. These are the main 4 points that we are going to discuss in today's class. हमारा क्लास में ये 4 पार्ट का डिस्कस करने वाले हैं. ये चर्चा करने के बाद I can guarantee you that you will be able to get at least 1 mark from the NEET examination. Always you prepare in such a strategical way where you are going to grab your medical seat and reserve for yourself by your confidence. Yes, है ना? Very good. और क्या? Kapilendra, how are you preparing for the NEET examination? Make it fast. Okay. Shohani Tiwari, hello. Many more students are there. Right. Now let us talk about the aromaticity first. Aromatic, anti-aromatic and non-aromatic compounds and the relative stabilities also. And eventually we go into the preparation of benzene and preparation of benzene, structure of benzene and properties of benzene, electrophilic aromatic substitution and direct influence of the mono-substituted benzene. Definitely you will be having an expected question from here and here and here. Definitely there is 3 points that are important for today's class, and let's talk about aromaticity. So aromaticity means, aroma means smell, characteristic smell. So aromatic compounds do have the characteristic smell, like coffee. Caffeine is an aromatic compound, it has a characteristic smell. Similarly aniline, you have a nitrobenzene, you have a benzaldehyde. Aditya, hi. So all these compounds do have the characteristic smell. Okay, so by closing our eyes we can smell it and we can say which compound is that because of their characteristic smell. Okay, aromatic compounds are not said that they are aromatic by their smell, rather aromatic compounds are said to their properties. You are new to this class, okay. So this class is a stream of these segments, okay. Today we are going to discuss, Aditya, about only aromatic. So however you are new to this class, you can attend the class and you can try to understand. Okay, don't worry. Aditya, how are you? Good afternoon. Now reactions of alkene and alkanes, you see. Why reactions of alkene and alkanes we are talking in the aromaticity? Yes, of course. If it is a cyclohexene, when it is treated with the alkaline called KMN4, which is pink in color, because of this reaction of alkene with alkaline KMNO4, it is going to form a diol. Because of that reaction, this pink color is decolorized. So our called alkaline KMNO4 is called a Bayer's reagent. Okay, this is what you call it as a Bayer's reagent. This Bayer's reagent is going to disappear its pink color. So this is a test for unsaturation. Alkenes and alkynes are going to give this particular test. So this is a test for unsaturation. Now my discussion is here. Does benzene behaves like this? Addition of Bayer's reagent to benzene? Yes, benzene, when you add Bayer's reagent, there is no change. Do not react at all. Q, Y, so cold KMNO4 in the alkaline medium. So there is no reaction. Q, Y. So the benzene, आपका benzene का जो structure है ना, एक बार देख लीजिए. And benzene, however, it has 3 double bonds in it. It is not behaving like ना alkene. क्या फर्क पड़ता है बेंजीन का जो आल्कीन का? जैसे बेंजीन में 3 डबल बॉन्ड्स है लेकिन बेंजीन आल्कीन का जैसे रिएक्ट नहीं कर रहे हैं. Why? Because benzene has resonance and delocalization and its aromaticity makes it is not able to react like that. So that's what I want to say. So the benzene, so these three bonds जो है ना, and they are oscillating here and they are changing their position, and this benzene structure आपको मिलेगा ऐसे आना. So that due to delocalization of the pi electron system. Hi Abhinav, how are you? Just pinging in the class can I can identify you. How are you, Abhinav? How are you, Abhinav? So Aditya, new student, is joined like you, and Kapilendra Pangi is there with us. Okay, anyways, however, the benzene has three multiple bonds in it, and benzene is not behaving like an alkene. Alkene undergo electrophilic addition reaction, but the benzene do not undergo electrophilic addition reaction because of the delocalization of the pi electron system. And due to delocalization of pi electron system, it is participating in substitution reaction, or rather addition reaction. Okay, let's talk about the resonating structures of benzene and the structure. In the ring, the electrons continuously revolve in a circular path like this. Thus, there is a sustained continuous current in the ring. That is your pi electron system. Yes, why should I forget you? Are my favorite student, I know. I remember. I love every student. I love every student, including you. Okay, so आप chat box में लगे रहो. Okay, you be free in the class. Aditya, hope you are understanding the concepts. ठीक है बेटा? Kapilendra? Yes, that's good. You please like and share these sessions with your friends so that they can also come and enjoy with us. ठीक है बेटा? हाँ, yes. Now let's talk about, if the direction of the ring current is diatropic, then it is a molecule is aromatic. And what is the concept of aromatic, we will discuss. If the direction of the ring current is paratropic, then the molecule is said to be anti-aromatic. So we will discuss about today what is aromatic and non-aromatic stuff. Okay, let's talk about the classification of the organic compound. So classification of organic compounds, cyclic compounds are said to be aromatic and aliphatic. Okay, and the compound is aromatic, anti-aromatic and non-aromatic. Aromatic compounds जो है, they are going to participate in electrophilic substitution reactions. Anti-aromatic compounds are not, they are actually unstable. Non-aromatic compounds undergo addition reactions, not substitution reactions. Okay, let's talk about the conditions for the compound to be aromatic. So पहला जो condition है, so there has to be a cyclic ring structure, and the ring must be the planar in shape. No atom in the ring must be sp3 hybridized. So all the atoms, all the carbon atoms in the ring should be sp2 hybridized. If a lone pair is present involving ignore sp3 rule. So if at all, if you want to say the planarity, if the lone pair is participating in this delocalization, you just simply ignore the sp3 hybridization rule. Rather, you can also say there must be fully cyclic conjugation. So there should be a resonance throughout the ring. So there should be fully cyclic conjugated system, and it should have Huckel rule. It should follow Huckel rule. An aromatic compound should have 4n plus 2 number of pi electron systems. If the compound follow this first point, second point, third point and the fourth point, then only you can say the compound is aromatic compound. Then only you can say the compound is aromatic compound. Okay, what is a non-aromatic compound? Let's talk about the non-aromatic compounds. Example, you can see if n is equal, then we can the following 4n plus 2 is equal to 4 into n is 0, 2. So there should be 2 pi electrons. if therefore the ring with 2 pi electrons is aromatic. I wanted to say 4n plus 2 is equal to number of pi electron system. So, from this solve for n. So, if n is equal to 0 or 1 or 2 or 3 or so on, the compound is aromatic. If the compound is aromatic, it should follow this. If the n is getting not as an integer, maybe a fractionally you are getting, it is said to be anti-aromatic. That is a simple logic I want to say. So, based on the aromaticity, anti-aromaticity, you will be getting a question directly or indirectly. We are going to discuss such questions also. Stay tuned in the class. Dear students, let us say here. So, similarly, if n is equal to 1, there are 6 pi electrons, okay, just like a benzene. Benzene is an example. If n is equal to 2, there should be 10 pi electrons, and if n is equal to 3, there should be 14 pi electrons. So, like that you can see benzene has all the carbon atoms in sp2 hybridized. You can see the benzene, this is your benzene. This benzene is a cyclic planar system. All carbon atoms are sp2 hybridized, so that it is a cyclic planar system. And if you see the resonance of the benzene, there is a cyclic delocalization. As a result of that, complete cyclic delocalization of the pi electron system. So, this is a resonating hybrid of the benzene, and it should have the 4n plus 2. 4n plus 2 is equal to how many pi electrons are there? 1, 2, 3, 4, 5, 6. 6 pi electrons are there. On solving, n is equal to 1 is coming. When n is equal to 1, it is compound is said to be integer. So, therefore, it is aromatic. It is aromatic. So, like that you simply apply the Huckel rule and you can say the compound is aromatic or non-aromatic or anti-aromatic. Not only this, many structures we can discuss it, and I just want to say, if more than one p orbitals are parallel overlap simultaneously, then there is a conjugation given one of them is filled with the other is vacant. So, what are the characteristic properties of the aromatic compounds? So, they have the characteristic smell I already mentioned you, and there is an extra. Aromatic compounds are super stable and they burn with a lot of smoke, flame. That is what you say, sooty flame. Okay, and talking about classification, aromatic, anti-aromatic and non-aromatic. Aromatic compounds are otherwise classified further into benzenoid aromatic and non-benzenoid aromatic compounds. So, what is a benzenoid aromatic compound? So, benzene ring should be present within the structure of the molecule above, and non-benzenoid molecule means so non-benzenoid means the other than benzene structures are there on the molecule, that is called non-benzenoid molecule. So, let us talk about benzenoid aromatic compounds. Molecule having at least one benzene ring in its system is known as benzenoid molecules. Say example, you have benzene, naphthalene, anthracene, phenanthrene. What is this? The structure of the naphthalene is a benzenoid and anthracene and phenanthrene. So, like that. So, how many pi bonds are there? 1, 2, 3, 4, 5 pi bonds are there. So, each bond contains 2 electrons, so that 10 pi electrons are there. When you solve it, 4n plus 2 is equal to 10 on solving n is equal to 2. Whereas here anthracene, do you have 7 bonds, so that 14 electrons. So, 4n plus 2 is equal to 14 on solving n is going to be 3. Like that phenanthrene is also coming into that way. talking about anti-aromatic compound. एक खतरनाक है. Mind it, whenever anti-aromatic compounds are there, they are super unstable. Whenever anti-aromatic compound is forming or ion is forming, you can just throw it away. It shouldn't happen because it is highly unstable. They are highly unstable. Let's talk about these are unstable compounds, conditions for anti-aromatic compound. Everything is fine, just like aromatic, but only Huckel rule में आपको धमकी मिलेगा. So they must be cyclic and they must be planar, okay, and there must be fully cyclic conjugated system, लेकिन उसमें 4n pi electrons मिलेगा. There must be 4n pi electrons where n is equal to any integer. You can say 4n plus 2 आप डायरेक्टली इस्तेमाल करना चाहता हूँ, अगर इंटीजर नहीं मिलेगा तो आपका एंटी एरोमेटिक होगा. Directly don't calculate Huckel rule, right? You have to check the first 3 points, then you can use the Huckel rule and can find out it is aromatic or anti-aromatic, right? My dear students, look at this. And these are highly unstable 1,3-cyclobutadiene. 1,3-cyclobutadiene is one example. Okay. Now, in this 1,3-cyclobutadiene, it is a cyclic planar, okay, and 4n plus 2 is equal to 2 electrons, 2 bonds are there, so that 4 pi electrons are there, n is equal to 1 by 2. So, this is not an integer, so it is an anti-aromatic compound. Clear? Fine. Next. So, non-aromatic compound, it could be anything. Yes, cyclobutadiene. Non-aromatic compound, the compound at either neither aromatic nor anti-aromatic are known as non-aromatic compounds. They are not related to, they may be missing a planarity, they may be missing kind of delocalization, and there is no sense of looking at this Huckel rule. Such compounds are said to be non-aromatic compound. cyclohexadiene, ये conjugated diene होगा और non-conjugated diene होगा. यह तरफ आपका sp3, it is not a planar system and there is no conjugation completely. Such kind of systems are said to be non-aromatic compound. And I just want to say the order of stability, इसका विषय से जाना है. सब लोग ये order of stability का एक बार ध्यान देना. Aromatic compounds are super stable as compared to non-aromatic compounds and anti-aromatic compounds. Anti-aromatic compounds are super unstable, whereas aromatic compounds are super stable. That's very important. Children, hope you are understanding. Clear? And based on the aromaticity, we can see which of the following aromatic hydrocarbon. So, is an aromatic hydrocarbon. So, put your response in the chat box. I want to see Kapalendra Pangi and Aditya and Abhinav. Come on, what is your answer? Moving ahead, this is a cyclobutadiene and this is a naphthalene and this is a non-aromatic and this is also non-aromatic. You can see cyclobutadiene is sp2, 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 but it do not follow Huckel rule. It is anti-aromatic, and it of course is naphthalene is aromatic, and these two are conjugation is missing here and here, and it is non-aromatic. Which of the following is an aromatic? Means this is your aromatic and this is your explanation I just want to give you, and everything it is the answer. B is the aromatic. You please join in the Telegram channel. It is there in the description box, so that you will be getting the entire notes as the PDF form for you guys, right? And based on the aromaticity, what is the order of stability in the given compound? Of course, this is aromatic, we know that. This is anti-aromatic and this is non-aromatic. So, aromatic is more stable than non-aromatic is more stable than anti-aromatic. So, that we can say the order of stability is 1 is greater than 3 is greater than 2, because this is aromatic, this is anti-aromatic, and this is a non-aromatic. Okay, now based on the characteristics of aromatic compounds, so why do aromatic compounds burn with a sooty flame? Because they have high carbon to hydrogen ratio, percentage of the carbon is more. Because of that, during burning, carbon fragments are coming in the vapor state, so that is called sooty flame. And talking about what is a new quasi-aromatic compounds. Quasi-aromatic compounds are actually, they are not aromatic, because of their charge they become aromatic. Such kind of compounds are said to be quasi-aromatic compounds. Just I want to say, because of the polarity you can say, here trophylium cation is quasi-aromatic compound, and cyclopentadiene anion is an aromatic, and also you can see cyclopropenyl cation is a aromatic, and also you can say characteristics of quasi-aromatic compounds. And actually you just say cyclopentane, this is your cyclopentane. Carefully you see, a super important point I am going to explain you guys. So, this is your cyclopentane, this cyclopentane, cyclopentadiene, and this is dione. So, and this is a cyclic system. Hi Rifat, hello, Sahaja, Sain, Rifat. Because of this pi electron system is shifted from here to here, because of that I am going to get a compound or ion like this, polarized ion like this. It is going to be a positive charge and it is going to be a negative charge. Now, this is a part of cyclopentadienyl anion and this is a part of cyclopropenium ion. So, now this was uncharged system and become a charged system. Because of this charged system, this ring becomes aromatic and this ring becomes also aromatic. So, this polarized system becomes aromatic. So, this is what you can say, it is a quasi-aromatic compound, is very important. Rifat, how are you beta? Kaise? Okay. So, let us discuss about some other things. They are soluble in polar solvent because of the charge, they are getting soluble, and they have high dipole moment, yes, because of the charges they have the high dipole moment, and also they have high boiling points and the melting points. Yeah, I am fine, thank you. How are you? Okay. So, let us see some more aspects here based on stability of molecules, and out of these two compounds which is more stable, such as Rifat, can you tell me which is more stable? And this is a stable due to resonance, this is a stable due to resonance, but trophylium ion has a stability due to aromaticity. Of course, this part is also aromatic, but this cation is not a part of aromatic, but this cation is a part of aromatic. So trophylium carbocation is stable due to aromaticity. But also you can say one more here, based on the stability, out of this cyclopentadienyl anion and a benzyl anion, cyclopentadienyl anion is having a resonance, and due to that resonance it acquires aromaticity, so it is more stable. Trophylium ion in the previous case, and here cyclopentadienyl anion is going to be in this case. Everybody in the live class right now, you please mention your answer in the chat box so that we can have a two-way transaction between you and me, right? Suhas, how are you nowadays? Hello. Nice. Rifat, come on. आगे और एक क्वेश्चन देना है. So preparation of benzene, everybody, let us talk about the preparation of benzene. How do you prepare benzene? Benzene can be prepared from alkanes. How? This is your N-hexane. It is heated in the presence of Cr2O3 and Al2O3. It is going to get cyclization followed by aromatization, gives rise benzene. Okay, this is what a reaction from alkane as well as a preparation of the benzene. So we are taking the advantage of 2-in-1 in the sessions, right? And talking about by cyclic polymerization of acetylene, when the acetylene gas is passed through red hot iron tube or red hot copper tube, it is going to get cyclic polymerization process to gives rise C2H2 3 moles gives rise C6H6. So this is an important reaction, and my answer is, if propyne CH3 C triple bond CH, when it is passed through red hot iron tube, could you tell me what is the product? Could you tell me what is the product? Somebody, Suhas and Rifat, come on. Abhinav expecting answer. Aditya, Kapilendra Pangi, come on. Who is going to give the answer here? Make it fast. Quick response. I am expecting quick response. Yes, it is going to get, yes, toluene. Rifat, it's not toluene. It is going to get mesitylene. You are going to get mesitylene. You are going to get mesitylene. है ना? Correct yourself. You have taken one methyl. What about the rest of the two methyl groups? That's very important, right? Now, let's talk about preparation of benzene from the phenolic compounds. When the phenol is oxidized, so reduced in the presence of zinc dust, you are going to get benzene. Also, you are going to get the cresol, you are going to reduce to give rise toluene, and that's your toluene. And also preparation of carboxylic from carboxylic acid, you can use decarboxylation process, and when benzoic acid is heated with soda lime. What is soda lime, Rifat? It's a combination mixture of sodium hydroxide and calcium oxide. Mixture of calcium oxide and sodium hydroxide is called soda lime. It is used for the decarboxylation process where carboxylic group is eliminated as carbon dioxide, and you are going to get benzene. If it is orthomethyl benzoic acid heated with soda lime, you are going to get toluene. And also preparation of benzene from Grignard reagent. When Grignard reagent, phenyl magnesium chloride is hydrolyzed. What is this? Sodium hydroxide and calcium oxide is called soda lime. That's a good response here. Children, you can see this Grignard reagent is an excellent nucleophile and good base. So it is going to react with so that it gives rise to benzene. एनी टॉपिक्स फॉर फिजिकल केमिस्ट्री? कौन सा टॉपिक चाहिए आपके लिए? मैं सिर्फ आपके लिए एक फिजिकल केमिस्ट्री टॉपिक्स देना चाहता हूँ. सुहास, चॉइस आपका. यू टेल योर ऑप्शन. सुहास, any physical chemistry topic, you tell me, I am going to present it in the next week. Promise. Okay, so let's talk about benzene sulfonic acid. When benzene sulfonic acid is hydrolyzed in the presence of acid, is going to give rise benzene. Thermodynamics, 30th of September. आई थिंक सेकेंड लॉ ऑफ थर्मोडाइनमिक्स पढ़ाने वाले में शायद मैं देखता हूँ. सेकेंड लॉ ऑफ थर्मोडाइनमिक्स. रेडी फॉर दैट? रेडी फॉर दैट? सो यू प्लीज अटेंड द लाइव सेशन. सेकेंड लॉ ऑफ थर्मोडाइनमिक्स हम साथ करेंगे. साथ साथ कर सकते हैं ना? नीट एग्जामिनेशन के काफ़ी इंपॉर्टेंट पॉइंट्स हैं. you used to come regularly in the previous sessions with me. Am I right, Suhas? You have a problem in identifying benzoyl compounds. Any trick to give? Yes, of course, benzyl. Benzyl means carbon that is what is a benzyl. Okay, and carbon that is called benzoyl. It should be something. It should be something. Rifat, you got your trick now? Whenever you ask a trick in the live class, you are going to get an awesome explanation for that, right? One problem is my college is till 5:30 na. Are do one thing, you just attend your recordings and all. You can do the best, no? You can attend the recordings of the session. You can write something in the comment box. As if you have any doubt, you can discuss with that. At night time, I am going to read these comments. I am going to repost the doubts, na? Me too. Rupesh, if anybody cannot attend my live classes, attend my recordings. As you are having a doubt in the live classes, you are asking me. Similarly, in the comment box, you can mention it, so that immediately I am going to answer that question there itself in the same day. है ना? Rupesh, happy? Okay. So let's go ahead about this benzene. Rupesh, you need not have to retract the messages. Let's talk about the preparation of benzene from benzene diazonium chloride. Benzene aniline, this is what you say, aniline. This aniline, when it is treated with NaNO2 and HCl at 0 to 5 degrees centigrade, the amino group is converted into diazo group. So this is what you call it as a benzene diazonium chloride. Simply you can say it is a BDC. This process of conversion of aniline to benzene diazonium chloride is called diazotization. This diazotization, so this BDC simply it is treated with He3PO2, or also you can use C2H5OH. You are going to get a benzene. Okay, this is very simple reaction, and you always learn the organic reactions in such a way that one is connected to another. Divani Rupesh, okay, Dhavni Rupesh. So let's talk about the structure of benzene, reactions of benzene. because of the delocalization of pi electron system, the benzene ring is not prone for addition reaction, rather they are prone for substitution reactions. What is the difference between azo and diazo? So azo means double bond and diazo means, okay, so N single bond N double bond N. है ना बेटा? So okay, so talking about electrophilic aromatic substitution reaction, most important reactions of the benzene are electrophilic aromatic substitution reactions. These are denoted as SE, substitution electrophilic reactions. That's a very, very important point. Okay, so because of the delocalization of the pi electrons, it undergoes substituted reaction. So this hydrogen is being substituted here by an electrophile, so that it is what you call it as electrophilic substitution reaction. So this is an electrophile. So what are these electrophilic aromatic substitution reactions? There are 5 reactions I just want to say. First, this benzene takes the first electrophile, so that it is the rate determining step, and it is going to give the various resonating structures of the sigma complex. So this hydrogen and this electrophile, and there is a resonance among them. So this positive charge that is just formed by the addition of electrophile is rotating here and there. That is what you call it as a technical language as a delocalization, where this delocalized this sigma complex, we have to say this is a sigma complex as an intermediate. This sigma complex, the pi electron become a newly formed sigma bond, and this is what you call it as a sigma complex. Okay, Suhas, and this electrophile is retained by the loss of proton. So you are going to get an electrophile being substituted on the benzene. So this is what you call this basic mechanism, termination of basic mechanism shown by this electrophilic aromatic substitution reaction. There are 5 golden reactions of benzene. I just want to show the 5 most common electrophilic substitution reactions of benzene is halogenation. This could be bromine, chlorine, iodine, okay, and nitration, and nitro group is substituted for a hydrogen, and you have sulfonation. So sulfonic group is substituted for hydrogen, and also you have Friedel-Crafts acylation and the Friedel-Crafts alkylation. These are the 5 basic reactions that you can say for the benzene aromatic substitution reaction. Okay, so whatever the other things are related to these only. I just want to say bromination. So this is your bromine. When it is treated with a Lewis acid, you are going to get the lone pair of electron present on the bromine is going to attack here, so that bromine free radical is formed. So get FeBr4 minus. So this Br is going to attack on the benzene to give rise the bromobenzene. Okay, so this could be chlorination in the case of chlorine and iodination in the case of iodine. So you can say chlorination, the same scenario you can see, you can use any Lewis acid. Electron pair acceptor is called Lewis acid, and electron pair donor is called a Lewis base. So in this case you can use any Lewis acid like BF3, BCl3, AlCl3, FeCl3, FeBr3, anything आप इस्तेमाल कर सकते हैं. So that you can say iodination. आयोडीनेशन जैसे प्रोसेस थोड़ा सा रिवर्सिबल प्रोसेस है. ये रिवर्सिबल प्रोसेस आगे रखने के लिए ऑक्सीडाइजिंग एजेंट आप इस्तेमाल करना पड़ता है, क्योंकि द प्रोडक्ट दैट इज फॉर्म्ड HI is a reducing agent. A reducing HI can make the reaction backward. So to go the reaction in the forward reaction, so a reaction आगे बढ़ने के लिए HI has to be consumed as soon as it is formed. इस चीज़ के लिए आप ऑक्सीडाइजिंग एजेंट HNO3 इस्तेमाल करना पड़ता. Okay, now let us talk about In the iodination, oxidizing agent like HNO3, HiO3 are used to oxidize HI, which is a reducing agent. Okay, and in the presence of sunlight, is very important. In the absence of halogen carrier like Lewis acids, when the benzene is reacting with the chlorine, you are going to get C6H6Cl6. This is a very funny compound. Okay, this is what you call it as a 666 compound. Gamma isomer of this is called gamaxane. Okay, and what is the use of gamaxane? Gamaxane is used as an antikiller, cheaty. Okay, now nitration. In the nitration, HNO3, mixture of HNO3 and H2SO4 is used as a nitration mixture, so that in the nitration lone pair of this is given to this. So, he is a proton donor. So, nitric acid is a Lewis base, mind it, nitric acid is a Lewis base. So, you are going to get NO2 plus as an electrophile, that is very important, electrophile, and this is going to react with the benzene to give rise nitrobenzene. Got it? This is going to react with benzene to give rise nitrobenzene. This is very, very important. The electrophile which is used in this reaction is the nitronium ion. Okay, and also you can see here sulfonation. In the sulfonation, you are going to get this sulfur trioxide and concentrated sulfuric acid is used as a mixture. So, sulfur trioxide is an electrophile. This sulfur trioxide, you can say sulfur trioxide is an electrophile. This sulfur trioxide is going to attack on the benzene. I wanted to say here, yes, double bond O, double bond O, double bond O. In this, oxygen is partially negative charge, so that sulfur is partially positive charge, is going to be reacting like this. Okay? So, this is what you can say a sulfonation. In the sulfonation, you are going to get benzene sulfonic acid as a product. Okay, and also you can say sulfonation of benzene is a reversible reaction. Mind, it's very, very important. ये चीज़ आप नीट के लिए डायरेक्ट इस्तेमाल कर सकते हैं. हमारा हर क्लास में NCERT बेस्ड और लाइन बाय लाइन आपको डिस्कस करने हैं. NCERT Express, you can say it is an NCERT Express. सो छोटे सा टाइम पर पूरा NCERT के हिसाब से पूरा कॉन्सेप्ट कर पूरा के पूरा आप डिस्कस करने हैं. And if the benzene sulfonic acid is heated in dilute acid, the reaction proceeds in the reverse direction. So, that is what benzene sulfonic acid on acid hydrolysis gives rise benzene, and the sulfur trioxide is regenerated in the acid is regenerated. And also you can say introduction of alkyl and acyl groups in the presence of catalyst is important. Actually, you study in such a way that you read a point from a book, that is of course obviously from NCERT, but you see AlCl3 is given in the textbook. Not only AlCl3 but also any Lewis acid can be used. Am I right? So, you can use AlCl3, FeCl3, FbCl3, okay, in the protonating agents like HF, H2SO4, H3PO4 are used. These are known as Friedel-Crafts reaction. You can see in this alkylation, benzene react with alkyl halide in the presence of a Lewis acid, you are going to get an alkyl benzene. So, this reaction is called as alkylation. So, Friedel-Crafts alkylation, polyalkylation takes place because of the alkyl group further activates the ring. So, acylation में ऐसा नहीं हुई होगा. I am going to discuss about. So, the above reaction can be achieved with an alcohol with HF, an alkene with dilute H2SO4, and also acylation. In this acylation, the benzene react with acyl chloride gives rise acyl benzene. This acyl benzene, so you can see acylinium ion, how it is generated? RCOCl or C double bond O and Cl in the presence of AlCl3. Okay, the lone pair of electron on the chlorine, the lone pair of electron on the chlorine, you can see you're going to give, this is a Lewis base and this is a Lewis acid. As a result of this, you are going to get R C double bond O plus AlCl4 minus. So this is what you call it as acylinium ion. It is an electrophile. This acylinium ion is attack on the benzene, gives us acyl benzene. आपका जैसे क्या होगा benzene? I just want to give the total reaction of the benzene react with acetyl chloride. CH3Cl, CH3C double bond OCl and AlCl3, and it is going to give you, it is acyl benzene, so acetyl chloride. So acetophenone, this is your acetophenone. Now mention in the comment box, Rifat and Rupesh, Suhas, what happened? Benzene react with benzyl chloride. Rifat, benzene react with benzyl chloride. What could be the product? Mention there. Somebody. Rifat, you have to. Benzene react with benzyl chloride in the presence of AlCl3. अरे मेरा सवाल है कि क्या होगा, मैं देखना चाहता हूँ, राइट? बेंजीन रिएक्ट विथ benzyl chloride in the presence of AlCl3. Answer? You are going to get the answer as benzyl chloride, or sorry, it is a benzophenone. This is what you said, is it? Benzophenone. ठीक है? Clear? Okay. Now, so there are 5 golden reactions of benzene. I just want to mention that. I just want to mention and just want to give the summary of it also. Okay, everybody focus here. 5 golden reactions of benzene. So this is your benzene. This benzene is reacted with halogen, okay, chlorine in the presence of AlCl3. That is what you can say chlorination, and you can say HNO3 and H2SO4. You can use H2SO4 and sulfur trioxide. You can say it is a sulfonation, fuming sulfuric acid or oleum. You can also mention this as H2S2O7, H2S2O7, है ना? This is what is sulfonation. You are going to get RCl in the presence of AlCl3 or FeCl3. If in the presence of RC double bond OCl in the presence of AlCl3 and FeCl3, doesn't matter. Okay, now let's talk about what is going to happen here. You are going to have chlorobenzene as a product. You are going to get nitrobenzene as a product. You are going to get benzene sulfonic acid as a product, and you are going to see alkylated benzene as a product. You are going to see the formation of C double bond O. So this is called acylated product. Now in this, what is the name of this? What is the name of this? This is what you call it a halogenation. Halogenation of the reaction. Halogenation reaction. Here this is what you call it as a nitration. nitration. This is sulfonation. This is what you say, it is a sulfonation, right? And it is going to get Friedel-Crafts alkylation. Friedel-Crafts alkylation, and this is what you call the Friedel-Crafts acylation. This is what you can say, it is a Friedel-Crafts acylation. So this is almost like a board level reactions, and उसमें क्या क्या चीज़ मिलेगा आपको नीट एग्जामिनेशन कॉम्पिटिटिव एग्जामिनेशंस में आपका आएगा. सो उस रिएक्शन में दिस इज एन इलेक्ट्रोफिलिक एरोमेटिक सब्स्टिट्यूशन रिएक्शन. ये इलेक्ट्रोफिलिक एरोमेटिक सब्स्टिट्यूशन रिएक्शन में इलेक्ट्रोफाइल क्या होगा, Cl plus is going to be the electrophile. Here electrophile NO2 plus is going to be the electrophile. Here SO3 is the electrophile, and here electrophile alkyl carbocation is electrophile, and R acylenium ion is the electrophile. ठीक है, got it. Now here Friedel-Crafts alkylation, very important point I just want to mention here. This Friedel-Crafts acylation alkylation rearrangement takes place. Rearrangement takes place, that's important. And polyalkylation also takes place. Whereas you can see, hi Richa Sharma, after a long time I found you. How are you, Betty? Right. When it comes to the Friedel-Crafts alkylation, you can say rearrangement do not takes place. Good afternoon, Richa Sharma. और एक चीज है ये वाला पॉलीएसाइलेशन डू नॉट टेक्स प्लेस. So in a single slide, total aromatic reactions I have given. Today we discussed about what is aromaticity and aromatic compounds. Aromatic, non-aromatic and anti-aromatic we discriminated, and I have given you the simple trick to say aromatic and non-aromatic. Later on we discussed about the structure of benzene and preparation and reactions of benzene, and these are the reactions of benzene in a one shot, and you all just take an advantage of this reaction of the benzene and what kind of reagents can be used, what kind of products that can be formed, and what could be the electrophile that is formed. Like that, every reaction you can get into that. Just let us talk about one more reaction here. Yeah, if this is the case, CH3 and CH double bond CH2, when it is reacted with benzene in the presence of HF, what could be the product? What could be the product? Richa Sharma, okay, Dhavni Rupesh and Rifat, you please give me the answer in the chat box. Fatafat. Richa, I am very happy to see you after a long time in the class. Okay, hope you are busy with your school timing that matches with me. You attend the sessions on the recording and you just mention your doubts in the comment box. And इसका प्रोडक्ट क्या होगा, इसका प्रोडक्ट्स क्या होगा, ये प्रोडक्ट आता है CH3 and CH double bond CH in the presence of HF gives rise H plus and F minus and this is your H plus. So it is going to be protonated, so it gives rise CH3 and CH and CH3, and it is going to be plus. When it is reacted with benzene, you are going, I don't want to put the mechanism over here, बिना mechanism डाल के आप आंसर दे सकते हैं, and it is going to be like this. So I just want to say it is isopropyl benzene. This isopropyl benzene is otherwise called cumene. Cumene. Got it? So today we had a great swell of the reactions of benzene, electrophilic, aromatic substitution. अगले क्लास में आपका आने वाला है direct influence of the benzene aromatic substitution reactions and their reactivity, ring activation and deactivation, everything. Get ready for the next class. Stay tuned. Please like the session and share with your friends and subscribe in the Infinity Land YouTube channel. And signing off, Suresh, Faculty of Chemistry from Infinity Land. Thank you very much. God bless you.